we're going to look at another theorem that has to do with triangles and their angle measures. And so this is called the exterior angle theorem. Alright, so the exterior angle theorem I'm actually going to describe in a diagram first, and then we're going to write the if then for it. So what it says is that if I have a triangle, and this is of course any triangle, it'll be the case that the measure of one of the exterior angles will be equal to the sum of the measures of the two non-adjacent interior angles. And so this is the reason I want to draw a diagram first is that when I go and write this here, it is kind of complicated how I have to word it, because I have to be very specific about the fact that this exterior angle, and then it's equal to the sum of the other interior angles, their measures, and not the one that's adjacent to it. So here's how I'm going to write it. So if a polygon is a triangle, then the measure of an exterior angle is equal to the sum of the two non-adjacent, oh, that's not what I wanted, undo, non-adjacent interior angle measures. There we go. Okay, so the question is why that's the case, and so it has to do with this. If I look at angle 1, angle 4 here, they're a linear pair and they're supplementary, so that means they sum to be 180 degrees. So angle 1, the measure of angle 1 plus the measure of angle 4 is equal to 180 degrees. Also, 2, 3, and 4, they're interior angles of a triangle, and so their sum will be 180 degrees as well. And so if 2 and 3 add to angle 4 to be 180, and 1 adds to angle 4 to be 180 degrees, this sounds a lot like our congruent supplements theorem from a while ago, except for 2 and 3 and 4 aren't supplementary. That only works for pairs of angles. And so instead, I have to set up an equation just like I did last time, and work with them that way. So that's fine. We'll go ahead and do that. We'll knock these out. So I need my given and my proof. So my given in this case isn't really anything. I could say that, triangle ABC, or rather polygon ABC is a triangle, or I could state that angle 1 is an exterior angle, but I really don't need any of those things. So I'm just going to focus on my prove and then use my diagram for everything. And so my prove in this case is the fact that the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. That's my goal. All right, so we'll go ahead and try and knock this out. So step number 1 is not a given, and so the question is, what can I just pull from the diagram here? And the answer is, well, I know that the measures of angles 2, 3, and 4, they add up to be 180 degrees, and that's just my triangle sum theorem. So I'm going to start with that. So statement number 1 is that the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 is equal to 180 degrees. This is a triangle sum theorem. It says that if a polygon is a triangle, then the sum of the interior angle measures is 180 degrees. And that comes from nowhere. That just comes from my diagram, so I don't need to cite it. So on to statement 2. So I've dealt with 2, 3, and 4 now. Now I need to look at 1 and 4. So 1 and 4 I have to connect together, and what I can pull from a diagram is the fact that they're a linear pair. So angle 1 and angle 4 are a linear pair. This is just assumed from diagram. That's one of the things I can pull straight from the diagram. Sum Theorem diagram. And then I can jump into, what does that mean if they're a linear pair? I know that they're supplementary. Angle 1 is supplementary to angle 4. And my reason for that, I put 2 again. This is 3. My reason for that is my linear pair postulate. It says that if two angles are a linear pair, then they are supplementary. I'm going to run out of room. Or am I? This comes from 2. Okay. And then I can turn them into an equation here. So statement number 3 will be that the measure of angle 1 plus the measure of angle 4 is equal to 180 degrees. And that just comes from my definition of what it means to be supplementary. I did it again. 4. That's totally readable. Okay. So my definition of supplementary. 2 angles are supplementary if and only if their measures sum to 180 degrees. And that comes from the previous statement, which was statement 3. Okay, so now that I have these two equations set up, I have that, let's highlight these. So these 3 angles add up together, get me to 180 degrees. And these 2 angles add together, get me to 180 degrees. So that means that they have to be equal to each other. And so that will be my statement number 5. This will be the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 4. That's 5. And so that is just the transitive property. If 2 things are equal to the same thing, they have to be equal to each other. Transitive property. So that comes from where the 2 things I connected, statements 1 and 4. And then this is going to be kind of a long statement here, so I'm going to make room for it. What I need to do is I just need to get rid of the measure of angle 4 on each side. So I'm going to subtract that out. The measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 minus the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 4 minus the measure of angle 4. That is my subtraction property of equality. Whatever I subtract from one side, I have to subtract from the other. Subtraction property of equality. And that just comes from the previous statement, what I'm subtracting, which was 5. And then I just need to simplify, and I am done. So statement number 7, the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle 1. And that is just simplification. So this ended up being a pretty easy proof. What it just required me to do was to link 2 equations together because they both sum to be 180 degrees. And then I was good. I could link my measure of angle 1, the exterior angle, with the measure of angle 2 and 3, the 2 non-adjacent interior angles. So again, the reason this all worked out for me is because 1 is whatever it needs to be to add to 4 to get to 180. And then 2 and 3 also have to add to 4 to get to 180. So 1, its measure has to be equal to the measures of angle 2 and 3 summed together. So this is the exterior angle theorem. It's going to help me a lot moving forward whenever I'm trying to calculate angle measures in regards to triangles and exterior angles.